Hello everyone and welcome to this video session on dimensional analysis. This video is made for engineering students who study fluid mechanics and turbo machine subjects. The study of the relationship between physical quantities with the help of dimensions and units of measurement is termed as dimensional analysis. Let us take a simple example of flow phenomenon in order to understand the importance of dimensional analysis. The water is entering the turbine powerhouse and rotates the turbine, thereby producing mechanical energy of rotation or power. Now, power is a variable or physical quantity and it depends on other variables like quantity of water, its velocity, force of water, properties of water like density and viscosity, dimensions of casing, turbine, powerhouse and nozzle, losses like frictional loss, hydraulic loss, etc. These variables are independent and they possess their own amount of effect on power. Variables which affect majorly on power formation are listed out and a physical relation will be derived using dimensional analysis. These physical relations in simple terms are called as equations or formulae. These physical quantities are classified into fundamental and derived quantities. Fundamental quantities are those physical quantities that cannot be expressed in terms of other quantities. For example, mass, length, time, temperature, etc. The unit of mass is kg and its dimensional form is capital letter M. The unit of length is meters and dimensional form is L. The unit of time is second and dimensional form is T. The unit of temperature is degree and the dimensional form is theta. These four are most commonly used in mechanical applications. Out of these four, mass, length and time are used in fluid flow problems and temperature is used in heat flow problems. Derived quantities are derived from fundamental quantities. For example, area whose unit is meter square and dimensional form is L square. Volume whose unit is meter cube and dimensional form is L cube. Density unit is kg per meter cube and dimensional form is ml raised to minus 3. Velocity unit is meter per second and dimensional form is l t raised to minus 1. Similarly, so many other derived quantities are given in the table. Dimensional homogeneity is the quality of an equation having quantities of same units on both the sides. A valid equation in physics must be homogeneous since equality cannot apply between the quantities of different nature. This can be used to spot errors in formula or calculations. For example, here you can see two formulas. In the first formula, there is a mismatch between left and right side dimensional forms. So the equation is not homogeneous and cannot be used or should be reviewed. Whereas second equation is homogeneous and can be used to find out velocity of water when the head value is known. Physical quantities can also be classified based on the dimensions as dimensional variables, dimensionless variables, dimensional constants and dimensionless constants. Dimensional variables have dimensions but do not have fixed value. Example, force, velocity, work, power, etc., whose value changes with respect to time but dimensions remain the same. Dimensionless variables have neither dimensions nor fixed value. Example, angle, strain, specific gravity, etc. They are dimensionless. Dimensional constant have both the dimensions and fixed value. Example, gravity constant, Planck's constant, velocity of light, etc. whose value don't change with respect to time. Dimensionless constant don't have dimensions but have a fixed value. Example, numbers like 1, 2, 3, 4, etc. and value of pi, value of e, etc. have only some fixed value. Dimensional analysis is used to check dimensional homogeneity and correctness of physical relation of the problems, thereby finalizing the equation for solving the engineering problem. Also, it can be used to derive formulae for flow phenomenon which depends on so many variables or physical quantities. Flow phenomenon could be anything like hydraulic turbines, pump flows, compressor flows, design of ducts, wind tunnels, study of wind, study of breathing in human and animals, flow of blood in veins, etc. Dimensional analysis includes model study, in which a model is made which resembles the actual prototype but will be in smaller size. And correctness of the formula which is derived is checked by doing series of experiments which will save money, time and efforts to greater extent. This concept of model study will be explained in the next video in detail. Very importantly, the result found from the dimension analysis can be converted into any system of unit like SI, CGS, FPS, MKS unit, etc. Dimensional analysis helps us in expressing the variables in dimensionless form, which is easy to use anywhere to solve the problem. Instead of creating a complex equation, a simple equation can be formed using only three dimensionless variables m, l and t, and this can be converted into any unit of system. Many complex problems can be solved partially with less time as compared to traditional method of using mathematical theories. On the other hand, there are some limitations associated with dimension analysis. Like, this method only checks units, not the correctness of the equation, and hence proper experiments must be done. Deriving the equation using numeric factors is difficult as they will have some effect on flow phenomenon, but in dimensional analysis it will be neglected. Sometimes flow problems depend on other factors including m, l and t, and that time we may end up with improper equation or physical relation. Mathematical expressions include trigonometric and exponential terms could not be solved using dimensional analysis. Also, this method cannot divide the problem variables into scalar and vector quantities. Methods of dimensional analysis includes Rayleigh method, Buckingham's pi theory, Bridgman's method, matrix tensor method, visual inspection method, differential equation method. We will discuss about Rayleigh's method and Buckingham's pi method in solving a simple engineering problems with less number of variables or physical quantities. The main difference between these two methods is, in Rayleigh's method, if number of variables exceeds 6, then getting the solution using manual calculation method becomes difficult as the complexity increases. In Buckingham's pi method, there is no such problem with the variables, but more the number of variables, more is the time required to solve the problem.